In today's lesson, we'll be learning about rate of change and initial value with a focus on graphs. In our first example, we have a graph. Our x-axis represents figure number and our y-axis represents number of blocks. Figure 0 contains 5 blocks, figure 1 contains 7 blocks, figure 2 contains 9 blocks, figure 3 contains 11 blocks, figure 4 contains 13 blocks, and figure 5 contains 15 blocks. You'll start to notice a pattern. As you increase by one figure, your number of blocks increases by 2. You'll see this repeated again and again. Therefore, my rate of change is an increase of 2 blocks for every one figure. Furthermore, my initial value would be 5 blocks, since that is the number of blocks in figure 0. I can now represent the situation with an equation, y equals rate of change multiplied by x plus initial value. I already determined my rate of change to be an increase of 2 blocks for every one figure. This is the same thing as 2 over 1, which is the same thing as 2 divided by 1, which is the same thing as just 2. Therefore, my rate of change can be simplified to just 2. Meanwhile, I determined my initial value to be 5 blocks, since that is the number of blocks in figure 0. Therefore, I'm going to put 5 as the initial value. Therefore, this situation can be represented with the equation y equals 2x plus 5, where y represents the number of blocks, since that is on the y-axis, and x represents the figure number, since that is on the x-axis. In our second example, we have a graph. On our x-axis, we have time, and on our y-axis, we have distance. At 0 seconds, your distance is 20 meters. At 1 second, your distance is 16 meters. At 2 seconds, your distance is 12 meters. At 3 seconds, your distance is 8 meters. At 4 seconds, your distance is 4 meters. And at 5 seconds, your distance is 0 meters. At this point, you'll notice a pattern. As 1 second passes, your distance decreases by 4 meters. You'll see this pattern being repeated again and again. Therefore, the rate of change is a decrease of 4 meters for every 1 second that passes. Meanwhile, your initial value will be 20 meters, since that is your distance at a time of 0 seconds. I can now represent this situation with an equation, y equals rate of change multiplied by x plus the initial value. I've already determined the rate of change, and that was a decrease of 4 meters for every 1 second, which is the same thing as negative 4 over 1, which is the same thing as negative 4 divided by 1, which is the same thing as just negative 4. Therefore, the rate of change can be simplified to just negative 4. We also discovered the initial value to be 20 meters, since you have a distance of 20 meters when your time is 0 seconds. Therefore, I'm going to write 20 as my initial value. Therefore, this situation can be represented with the equation y equals negative 4x plus 20, where y represents the distance, since that was on the y-axis, and x represents time, since that was on the x-axis.